Hey 7th graders, today's lesson is the 3.2 matter and energy. Your learning targets, I can describe how carbon fluctuates in different parts of an ecosystem, but the total amount of carbon never changes. So we're really going to focus on different parts of our ecosystem that we've learned about so far, and we're going to look at the numbers of carbon in those parts, and what we're going to see is if it increases in one part of the ecosystem, other parts will see a decrease in, but if we were to add up the total carbon for that ecosystem throughout these changes, that total carbon shouldn't change. It should just show movement throughout the ecosystem. And really that's what we're focusing on with the carbon cycle. All right, activity 1, as usual, is your notebook. These are the last things you need to add to your notebook for this unit. So go ahead and open up OneNote, add key concept 9 and 10 to your key concepts page. All right, so number 9 says, since carbon cannot be produced or used up, the total amount of carbon in a closed ecosystem does not change. So this really focuses on the scientific law that matter cannot be created or destroyed. So we don't just have carbon appearing out of nowhere. It's got to come from somewhere. Okay, and we also just don't have carbon disappearing into thin air. It has got to come from somewhere. Okay, it's got to go somewhere. It doesn't just disappear. All right, and then 10, if the amount of carbon increased in abiotic matter, then it also decreased in biotic matter. Okay, and vice versa. If the amount of carbon decreased in abiotic, then it also increased in biotic matter. So again, that's just saying, all right, if we have a closed ecosystem and we see carbon going up maybe in the air, which is abiotic matter, that must mean we have less carbon in all of our things like producers, primary consumers, decomposers, stuff like that. And vice versa, if we have less carbon dioxide in the air, that must mean we have more carbon being produced or used up in those organisms that are living. Okay? All right, moving on to your warm-up. Open the Carbon in the Global Ecosystem article. We read this at the beginning of this unit, or you should have read this at the beginning of the unit. Notice that you're only going to read paragraphs 4 and 5. It should be a reread. You guys should have already done this. This article should be familiar to you. And then we're going to answer the question on the next slide. So let's go ahead. This is our link right here. We're going to right-click that, open it up. It's going to take us into our library. And remember, you guys are just reading paragraphs 4 and 5. So we've got 1, 2, 3, 4, and our unit, or excuse me, our little subheading, the carbon cycle, is the little section that you guys are reading. So here's the 2 paragraphs that you'll be reading right under the picture of Earth being a closed ecosystem. Okay, so reread those, and then you guys will answer this question. Open the Carbon in the Global Ecosystem article, answer the question on the next page. Use evidence you found in the article to answer the investigative question. If the amount of carbon changed in one part of the closed ecosystem, remember Earth is a closed ecosystem, what happened to the carbon in the rest of the ecosystem? Okay, so we don't necessarily know which specific part they're referring to in this question, so we're going to assume any part. If it increases in one part, what happens in another? And then use some direct evidence out of this article to help you. Okay? All right, moving on to activity 3, a little simulation for you. Your goal is to increase carbon in the atmosphere. So if you guys have messed with this a lot where you guys have changed the amount of carbon in different places or changed the amount of energy storage molecules, things like that. Okay, what we see is in Earth today, we are having some environmental issues as far as carbon dioxide being a greenhouse gas and having a little bit too much carbon dioxide in the atmosphere, okay? And one of the problems that this causes is, you guys can see if you ever were to drop dry ice, which is solid carbon dioxide, okay, same as what we see in the atmosphere. If you were to drop that in water, it actually turns the water acidic. So if we have too much carbon dioxide in the atmosphere, it's slowly turning all of our oceans and lakes acidic, which makes it really hard for certain organisms to survive, including things like coral reefs. Okay, so in the Carbon in the Global Ecosystem, you read that unlike what has happened in the biodome, which we talked about earlier in the year, or earlier in this unit, the amount of carbon in Earth's atmosphere is increasing. Your mission is to use the sim to model the global ecosystem by increasing the amount of carbon dioxide in abiotic matter as much as possible. So you guys will go ahead, right-click, open your sim link. It's right up here for you. You guys will open the sim, press play, and run in the default settings. And then you guys are going to make whatever changes you need to increase the carbon dioxide in the abiotic matter. And what I mean by abiotic matter is the air right now is probably our biggest piece of abiotic matter. And really that's what we're working on modeling. So I'm going to go ahead and press play. And then take a screenshot of the info view or graph view showing how much carbon dioxide is in the ecosystem and upload it. Okay, and then we'll have a question to answer. All right, so you guys will change whatever you need to on here. There's different things you guys can do. You guys can trap carbon dioxide. You guys can kill producers, consumers, secondary consumers, decomposers, and see what happens there. You guys can reset if you need. You guys can burn or bury energy storage molecules. You can either burn them or you can bury them and see what happens there. You guys can tweak the amount of sunlight. So figure out what you guys need to do to increase the amount of carbon dioxide. Once you guys see more carbon dioxide being pumped into the atmosphere, you guys will go right down here to your info view. Okay? What you guys are going to be looking for here is this green line right here. And if you wanted, you guys could totally uncheck everything else. So we're looking at carbon dioxide in the air, okay? Or you guys could look at both of these as well. It should be about the same number. So what you guys should see is if you've done this properly, this line should start to go up. So you guys will pause that when it goes up, and then you guys will screenshot. Remember, if you guys are using something other than a Chromebook, you guys can search for your snipping tool, hit new, click and drag, and then copy Control-C and paste Control-V your little screenshot onto slide 6 here. If you guys are using a Chromebook, you guys hit Control and Shift and hold those two keys down while you guys hit the little key right above the number 6. Okay, then you guys can again click and drag. You guys can click Capture, copy to clipboard, and then you go right in and go Control-V to paste. So it's super simple. I can help you guys out if you are struggling with it. But you should have a picture of your guys' graph there. It just needs to be of this square. It doesn't need to be of your whole screen. Okay? All right, moving on. Answer this question. As you increase the amount of carbon dioxide in the air, what happened to the amount of carbon in other parts of the ecosystem? Explain your answer. So you guys can, again, go back to your graph, and then you can turn on carbon in the ecosystem. You can turn on carbon in the biotic matter and just kind of take a look at what happened to all these different things. And then observe, too, what happened to your total amount of carbon in that ecosystem. Okay? Next part, another sim. So earlier in this unit, we watched a video from an experiment conducted in the 90s called Biosphere 2. Okay, and you guys got to see Jane Pointer talk a little bit in a TED Talk about her experience in Biosphere 2, but you guys also got to see kind of a brief overview of how they set the experiment up, what they expected to happen, but then what actually happened in the experiment. So one issue with Biosphere 2 was the lack of carbon dioxide in their ecosystem due to a decreasing number of decomposers. So they didn't have enough decomposers cycling through matter and energy in their ecosystem. So as we learned, this carbon didn't just disappear, it had to go somewhere else. And since they were living in a closed ecosystem, the carbon was hiding somewhere else in Biosphere 2. So this is your goal. First, you're going to make a prediction. What happened to the carbon that used to be in the air? So it would have been up in the air. Where did it go? So they actually had less air for them, okay, and less for photosynthesis. So choose an option to predict where the carbon went. So use your guys' draw tool to circle either A, B, C, or D. And then you guys will test it out. Again, you need your sim link for this. Open the sim, press play, and run the sim using default setting for 20 time units. So as we've done before in the past, you guys will hit play, you'll let it run for 20, and then you guys will pause it. And then you guys will make your change. So in this case, we found out that Biosphere 2 lacked decomposers. So you guys will press pause, and you will kill all the decomposers. So use this button right here to kill. Once all of these little pictures of the decomposers have disappeared, then you know you have completely killed all of the decomposers. Okay, and I'm not so sure that everything died in Biosphere 2 as far as the decomposers, but enough where it affected the amount of carbon dioxide in the atmosphere. Okay, so in this case, like I said, if you guys want big results, you need to make big results, so of course kill all the decomposers. Okay, and then press play and run it for another 100 time units. As the sim runs, observe what happens to the carbon in different parts of the ecosystem. Where did the carbon that used to be in the abiotic matter go? Hit check info view and look at the amount of energy storage molecules changes in each part of the ecosystem, or look at the graph and use the graph molecule preset. All right, so let's take a look at our graph. If you look at this, graph molecules, you guys can see amount of carbon dioxide ESMs here, or if you guys go to graph carbon, you guys can take a look at the total amount of carbon as well, and then the total carbon in your biotic matter, which is your living matter like producers, consumers, is that light blue color, and then total carbon in the air is that purple color. Okay, so you guys can kind of observe what happens, like I said, or you guys can do graph molecules here. Okay, when you guys are done, you'll need to screenshot that and show what happens. So you guys will kind of want to drag it back to where you made the change, so at about 20 time units, and start highlighting what happens to those different carbon molecules. Okay, then answer this question. Was your prediction correct? Explain why or why not. So why were you correct? What do you think was happening that made your guys' guess correct? Or why were you incorrect? What was wrong about your guys' prediction? All right, finally, we have 2 more activities left. This one, for you guys who are DLI, you will need to call and schedule a time for me to do this with me. I couldn't figure out how to get it in a PowerPoint slide for you guys. It's like a little board game, and it just had too many cards for me to give you guys an option to do in this PowerPoint without just making this a mess, okay? So I only have a couple DLI kiddos, so figure out a time that you want to call and play this game with me. It'll only take probably about 5-10 minutes. So you guys can kind of skip through slide 13 through 19 for now, okay? But again, when you guys call in and do this game with me, we'll play together, and then you guys will be able to answer the questions on 17, 18, and 19, okay? If you guys are absent and you guys will be back in class, you guys will need to find a time to make this up with me in the next week, okay? So you guys have about a week to make it up before we take our test, and this is all finally due. All right, last little section. Activity 6, cause and effect. So cause and effect in the biodome. Open the matter and energy and ecosystem sorting tool activity. It's actually on the next slide, so you don't have a link for that. And follow the instructions. You need to talk to a partner about your ideas as you work. Use the words from the word bank, and you guys don't have to worry about that in your discussion, as a lot of you guys don't have a partner at home anyway. All right, so your goal is to show the series of cause and effects that happen in the biodome system. So again, this is kind of our biosphere. You guys just learned a little bit about where the carbon went, so you guys should have an idea of what that process already looks like as far as the cause and effect. So you're due, order the cards in a way that shows how buried dead matter was the cause of the plants and animals in the biodome not having enough energy storage molecules. Your tips, the first and last card for this chain, are already in the correct locations. So you guys can see here's the first and here's the last card. So your very first thing that happened was that the econauts buried dead matter. So what happened next? And your goal to get to is that the plants and animals did not have enough energy storage molecules. So what happens when the econauts buried the dead matter? So find the next card you have out here and fill that spot, and then it should just be a big long system of cause and effect there. So place these 4 cards in the correct order to show the sequence of what happened in this little cause and effect relationship to cause the plants and animals to not have enough energy storage molecules. Okay, and then finally complete your wrap up. If you have any questions, circle yes or no. If you have any questions, type them below. Obviously, if it's preventing you from completing this assignment, make sure you guys let me know so I can help you out. And then 4, 3, 2, 1, how do you think you did? All right, you guys are all done. Please go ahead and hand it in, and I hope you all are having a great day. I'll talk to you soon. Bye.